Next, let's take the second chapter where we'll be focusing on inside our earth. It's important for us to see what exactly is there inside our earth, what is the structure and all. How did we come to know? How exactly are we planning to look into these aspects? All these will be learned in next chapters, where with the help of theories we will be trying to understand how exactly we came to know about what is there inside our earth. For this we took the help of earthquakes and we also took help of certain sources. These sources are actually divided into direct sources and indirect sources, and different types of it will be seen later. But as of now, it is important for you to understand what is there inside our earth, what are the structures, what is the volume of it, and how each layer is different from other. Here we will be trying to see the composition of the minerals present in these layers as well. So quickly let us see the interior of the earth, where can you observe, first you have crust and you have mantle. In between this you have lithosphere, right? That is crust and upper mantle. They actually form part of lithosphere. We have already seen the definition of lithosphere. Then you have inner core and you have outer core. So we need to see what are all these and how exactly the earth structure is formed. Before we go, it is believed that we cannot dig deeper into the earth. That is, we cannot dig from crust to inner core. The reason for this is, with increasing depth, temperature increases. So beyond a particular point, we cannot dig and go deeper. The deepest point which is seen, according to the NCERT book, is in South Africa. But now in Kamchatka Peninsula and at other places, you see that further the drilling has taken place with new equipments. When we drill till 4 kilometers or maximum 6 kilometers, we come to know what is there in that 4 to 6 kilometers. But we don't know what is happening inside, whether it is liquid, solid, whether density increases or not. To understand all these things inside the earth's crust, it is important for us to ensure that we go in detail about what helped us. That I told you we'll be seeing in 11th standard. But now it is very, very important for us to look at some of the factual informations with respect to this, which can be asked in prelims and also in mains. So what exactly is this? First is crust. The uppermost layer of the earth's surface is called as crust. And then below this you have mantle and then you have core. So let me just explain you some concepts with respect to this. It is believed that entire earth was in the liquid format in the beginning. Now what happened? Heavier particles came to the center. It is believed that entire earth was in liquid format and it was rotating and revolving. When this was happening, the heavier particles which were at the periphery or anywhere, they came to the center, and the lighter particles were present at the outer space or outside. So you usually get 3 or 4 layers. The first, we call it core, then you have mantle, then you have crust. Is it fine? So we got core, mantle, crust. The core is further divided into outer core and inner core. Okay, so you have outer core and inner core. Now, if I remove crust completely, I will be exposed to a different layer called as mantle. And if I remove mantle completely, I will be exposed to outer core, and if I remove outer core, I will be exposed to inner core. So people say that it is similar to onion wraps. That is, you have multiple layers in onion. So once you peel off one after the other, you usually see that one layer is completely different from the second layer, and the second layer is completely different from the third layer, so you can remove it. So they give an example of onion that earth is also present in this, but the thickness of each layer varies. So this is the first concept. The second important thing they say is that, now let me take the crust portion alone. I am not talking about anything else, I am talking only about crust. Now when I take crust, this is the outermost layer, isn't it? Correct? And after this, what is there? You have atmosphere. Correct? Now, due to crust being exposed to atmosphere, and it is the outermost layer, we usually observe that crust cooled first. So crust cooled first, that is, it became hard, and then the particles which were there inside, they took time to cool. The reason is they are present inside. So we usually see that first crust became solidified, then there was mantle and core which were still in its soft phase. And at this point of time, usually there were some gaps. So if I take crust again, and you have liquid or soft particles inside, there were some gaps. It's not uniform across. Now what happens? This is a solid particle, or this is also getting solidified, but there are some gaps in this region. Now the crust started breaking at these gaps, right? So due to this, we will not see uniform crust throughout. The crust is actually broken into several pieces wherever there are gaps. It is like I would just take a ball and I compress it. So whenever I compress, so the portions where I compress, it goes down, and other side it will be bulged. But when I compress on all sides, the space reduces, but there is a possibility that there can be cracks also. That is, just take a ball, compress it from all sides for long, you can see some cracks coming up, correct? So these cracks actually developed on the Earth's crust also. Once these cracks developed, the Earth's crust got divided into different plates. We call plates. Now, if you have a plate dominated by oceanic landforms, or if it is part of ocean, we called it oceanic plate and oceanic crust. Those which are part of continent are called as continental crust. Is it fine? I hope you are getting. Crust is not uniform, they are broken into pieces, and the one which is below oceans are called as oceanic crust, and the one which is part of continent are called as continental crust. When you have oceanic crust and when you have continental crust, in between these two, we are also talking about some plates which are part of both ocean and continent, which we will be seeing in later classes. But as of now, you should understand there is oceanic crust and continental crust. And the second important aspect that you people have to understand is, if you take mineral composition of oceanic crust and continental crust, they are not uniform, they are different. Here we see the continental crust is actually made up of silica, and they are also made up of aluminium, whereas the oceanic crust is made up of silica and they are made up of magnesium. So in short form, they took Saima. Al. So they call Sial, Sayal, or Saima, Sima, however you pronounce. Silica, aluminium is part of continental crust. Silica, magnesium is part of oceanic crust. We also understand that Saima is denser. That is, the weight of Saima is more when compared to Sayal. So it is lighter. So can I say that oceanic crust is denser and continental crust is lighter? So this happened in the Sial and Saima as well. And the reason for this is Sial and Saima. Now, when we look at the thickness, continents has mountain ranges, correct? If I have a crust, you have mountains and you have plateaus, and this is my land form. When I talk about oceans, I am talking about oceanic crust. So you have land or territorial crust and you have oceanic crust. And the thickness of oceanic crust is less, even though it is same here. Can you see plateau? It will be more. Mountains, it will be much more. So because of this, we usually see thickness of continental crust is more when compared to thickness of oceanic crust. But weight wise, we usually observe that oceanic crust is denser than the continental crust. I hope you are getting the point. Thickness wise, let me take cotton and let me take iron. Oceanic crust is iron, it is heavy, though cotton is bigger in size, it has less density. So usually when I place cotton and when I place iron on water or on liquids, what will happen? Iron will go down and liquid or soft one will be usually present above. Cotton will be present above. So can I say, if I have a liquid, iron will submerge more and cotton will submerge less. So due to this, we see different phenomena like Himalayas and other things in different parts of the world, which we will be understanding further. But as of now, I want you to look at these facts carefully once. So now let us see what the NCERT talks about this. So it says, just like an onion, the earth is made up of several concentric layers with one inside another. Is it true? I told you. You can peel off one after the other. The uppermost layer over the earth's surface is called crust. I have told you this. It is the thinnest of all the layers, but that is when we are comparing mantle and core, it is the thinnest. It is about 35 kilometers on the continent masses, and it is only 5 kilometers on the ocean floors. So these two are also important. Then we have to see the main mineral constituents of continental masses are silica and aluminium. This I told you. The oceanic crust mainly consists of silica and magnesium. This also we have seen. Now let's see some other factors. Just beneath this, you have mantle, which extends up to a depth of 2,900 kilometers, right, below the crust. And then you have the innermost layer of the core with a radius of about 3,500 kilometers. Can you see? The core is the innermost layer. It is mainly made up of nickel and iron. NiFe, nickel and iron. So you have crust made up of silica, aluminium, magnesium. Continental crust is made up of silica and aluminium, and oceanic crust is made up of silica and magnesium, and the core is actually made up of nickel and iron. So these facts are also important. Now once we go down, we have to talk about the rocks and minerals. So again, let us see what exactly are these rocks. It is believed that we have crust, and in mantle, in some portions, magma is there, or once it come out, we call it lava. Here, you see it is not completely solid or completely liquid. I call it viscous, similar to wax, right? It is similar to wax. Now, what happens in wax? You can usually observe whenever it gets heated, it becomes liquefied, again it gets solidified. So, that layers is usually found in the mantle. Below crust, in the upper mantle, we call, you have asthenosphere, so which is wax like layer here. And many people say the reason for this stage, that is viscous state of the magma, is the presence of radioactive elements, right? You have radioactive elements present in this region. Because of this, radioactivation, whenever it happens, it generates heat and it cools, right? Now, I told you crust is broken at several places, correct? Now, what happens if I have magma layer and the crust is broken like this, right? So, you have crust is broken. Now, this magma comes up. Magma comes up through the cracks. That is, if I have something like this, crack is there, magma flows up. When it flows, what will happen? It will melt this portion, correct? So, either magma coming out, or when magma comes up, it melts the rocks whichever it comes across. These type of rocks are called as igneous rocks. I hope you are getting the point. Igneous means fire, that is through melting of the rocks, whichever rocks were there. Any rock, if it melts and if it comes out and if it flows, we usually call it as igneous rocks. I hope you are getting the point. We are talking about igneous rocks. How did they form? I told you they formed because of melting of the rocks. Now, let me take crust. There is some crack here and crack here. Through this crack, magma is coming up, correct? Let me take, there was some cracks in this direction also. And there was some cracks like this. Different structures came up, okay? Now, whenever magma flows above, one will enter into this and another one will enter into this also, and some will come up, correct? The one which comes onto the earth's surface is cooled quickly. Why? Because it is exposed to atmosphere. So, magma comes up and it gets exposed to the atmosphere, it spreads and it becomes cool. As it spreads and it becomes cool, it doesn't have much time for cooling. So, as soon as magma comes out, it moves out and it cools. So, because of this, we usually see the particles which are present in the rocks formed on the earth's surface, which are exposed to atmosphere. The particles which are present in these rocks are very, very small. Whereas, if you consider this particular portion, here what happened? I usually observe that the temperature is more than here, correct? Here temperature is less. I told you with increasing depth, temperature increases. So, we usually observe that in this region, temperature is more, and in this region, temperature is less. Now, as you are observing, temperature is more in this region, and there is no much space for the particles to spread and cool. Usually, the particles come closer, and they take time to cool. Because of this, the rocks which are formed in this region will be usually having big granules. Here there are small granules, here there are big granules. Example of this is basalt rock. I talked about this in Deccan Plateau, black soil, and the example of this is granite. So these two are very, very important for us, and here we are actually talking about igneous rocks. So the rocks which were formed inside the crust is actually called as intrusive igneous rocks, and the rocks which are formed outside is called as extrusive igneous rocks. So you have to read both intrusive igneous rocks and also you have to read extrusive igneous rocks. This is one form. Now let me take another scenario. You have mountains, you have plateaus, river flows on this region. Whenever river flows, what does the river do? River erode it, correct? So if water goes and keeps hitting the rock continuously, what will happen? The rock will break into small pieces over a period of time. Let me take hundreds of years, small pieces. Now the river will carry these small pieces across, and let me take, you have a pond. Now all these will be deposited in the pond or sea, correct? So what happens? First I have deposition once, and later I will see further deposition, later I will see further deposition. Can I observe that deposition is taking place? And can I say the first layer which was formed, above that you have several other layers of sediments falling on it? So initially the first layer was calm, but later the pressure increased because more layers started adding. So the sand particles which were actually there, they started hardening. They became hard and they became rock. So because of the sedimentation of the rocks, if we usually observe rock formation, we call it to be sedimentary rocks, correct? Here you have to understand one more phenomena. In igneous rocks, I told you magma burns it and it liquefies and comes out. If fishes, human beings, animals, anything comes in between, it turns into ashes. But in the sedimentary rocks, take for example, in the pond, first sedimentation took place. This is your sand. Then one fish died. You have plants falling down. Then what happened? Another layer fell on it. When another layer fell on it, you usually observe here the species, they were also compressed. And if you have plants, and on the plants, if sedimentation takes place continuously, we see coal formation from the plants. And if you have animals, fishes, and if sedimentation takes place on that, you usually see oil. So we say fossil fuels are usually present in sedimentary rocks. Why? Because it formed one after the other, and above that when layers were formed, over a period of time you see the entire structure becoming rock. And after that, because of wind or because of oceanic influence, there may be sedimentation, that is sand and other things may be deposited. But below that the rock that is formed is harder, and between this you have fossil fuels. So where are fossil fuels present? They are present in sedimentary rocks. Now the third important thing, I hope you people would have seen boiled egg. When you actually take a normal egg, we usually observe that there is liquid inside, right? But when we boil it, you see a hard layer being formed, isn't it? So what is this difference? Why do you see a liquid one before and a hard one after that? What is the reason for this? It is believed that when we boil, the properties of the egg changes and it forms boiled egg. Similarly, rocks, any rocks you take, either igneous rocks or sedimentary rocks, when you subject it to high temperature or when you subject it to high pressure, we usually observe there is changes in properties of the rocks as well. So these type of rocks are actually called as metamorphic rocks. It's very, very important for us to look at this. Here we are talking about heat and pressure being added, and we call this to be metamorphic rocks. So you are talking about three rocks: igneous, sedimentary and metamorphic rocks. See guys, you have igneous, sedimentary and you have metamorphic rocks. So now my question to you, if sedimentary rocks are heated and it is pressurized, can I say it becomes metamorphic? When igneous rocks are heated and if pressure is applied, can I say it became metamorphic rocks? Correct? Now, let me take sedimentary rocks. If magma comes, melts it, and if it brings it to the surface, it becomes igneous rocks. The action of magma important. Can I say metamorphic rocks can also be liquefied by magma and it becomes igneous rocks? And then let me take rivers, wind, ocean. They erode igneous rocks and they form small particles and deposit, which form sedimentary rocks. And the metamorphic rocks may also be broken into small pieces to form sedimentary rocks. This process where each rock can be divided into other rocks is called as rock cycle. So these are some of the basics with respect to this. Let us quickly look at NCERT what they usually talk. So here when we are talking about the rocks, the Earth's crust is made up of various types of rocks. Any natural mass of mineral matter that makes up Earth's crust is called as rock. So definition is also important. Then there are three types. They are talking about igneous rocks, sedimentary rocks and metamorphic rocks. I told you igneous means fire. Sedimentary means sedimentum, that is settling down. Metamorphic means change of form. I told you egg became boiled egg. So this is the actual meanings. Now, which is the first rock which was formed from the lava or the molten one? It is igneous rocks. So it is also called as your primary rocks. There are two types of igneous rocks. I told you rocks which are formed inside the earth crust as intrusive rocks, and the one which is formed outside is called as extrusive rocks. Lava is actually fiery red molten magma. I told you if it is present inside the earth, we call it magma. Once if it comes out of the earth crust, we call it lava. When this molten lava comes on the earth's surface, it rapidly cools down and becomes solid. I told you, once the magma comes out and exposes to the earth's surface, it expands and it is also cooled quickly. So you get extrusive igneous rocks. And what is the property of this? Here you usually see very fine grained structure. Example of this, basalt. I have already told you. UPSC has started asking you questions on examples. So it's important for you to remember basalt is extrusive igneous rock. Then sometimes the molten magma cools down deep inside the earth's crust, and solids which are formed inside this is called as intrusive igneous rocks. Since they cool down slowly, they form large grains, and the best example of this is granite. So here you have to remember, grinding stones used to prepare paste or powder of spices, and grains are actually made up of granite. Even this can be asked. So please be careful. Rocks, they roll down, crack, hit each other and are broken into smaller fragments, and these smaller fragments when they accumulate are called as sediments, and they are carried by wind, water, ocean and all, and then they are compressed and hardened to form layers called as sedimentary rocks. Here can you see the layers being present? I am clearly telling you again and again. I have already explained you. I am just reading the notes. Just think that this is your notes. For example, sandstone made from grains of sand. This is very, very important, and I told you they contain fossils of plants, animals and other microorganisms which once lived. So they are rich in fossil fuels, so they are rich in oil and coal. Igneous and sedimentary rocks can change into metamorphic rocks under heat and pressure. Did we see this? That is, if you take clay and put more pressure or temperature, it becomes slate. If you take limestone and apply pressure or heat, it becomes marble. So this is very, very important for us. So at last, we should also see that rocks are very useful for other purposes. These are not asked in UPSC. This is only for understanding for the NCERT guys, not for you people, right? So it's important for you to look at this. And two important factors: Red Fort is made up of red sandstone. Taj Mahal is made up of white marble. Sandstone is, we just studied now, sandstone is a sedimentary rock. Marble, metamorphic rock. These can also be asked, so please be careful. Then I explained you about the rock cycle. It is given here. So just go through this. This is enough. So guys, we have seen in the beginning about the atmosphere. Now we saw different rock structures, intrusive, extrusive and all. There are different examples for this intrusive and extrusive. I will try to explain the examples or different types in future, but I will not be explaining you these, how did it form, that is how sedimentary formed, how igneous formed, how metamorphic formed, that we won't be looking at. But directly we will be taking those examples, and I'll show you different structures and the names given to these intrusive and extrusive igneous rocks, right? So let's quickly move to the next chapter.